Hello viewers, now I am going to teach you alkenes. So the learning outcomes of alkenes. Number 1, homologous series and their characteristics, their general formula, their names and structure of first 3 branched and unbranched alkenes. Now I'm telling you that there are 3 branched or unbranched, but I'm going to teach you 4th one also, just to make things little more clearer. Now alkenes. Alkenes are a homologous series of hydrocarbons that contain one or more carbon-carbon double bonds. I have told you homologous series before in my lecture of alkanes. Now I have drawn the structure of ethene. You can clearly see a double bond between 2 carbon atoms. And as I have told you before, the double bond is its functional group. Both double bonds are covalent bonds. The general formula for alkenes is CnH2n, where n is the number of carbon atoms. N can be 2, 3, 4, and so on and so forth. Well, alkenes, they start with 2 carbon atoms because we need at least 2 carbon atoms to form a molecule. So the first is, if carbon are 2, so you put the formula, it comes to be C2H4. If you write down carbon 3, it comes to be C3H6. If you write carbon 4, it comes to be C4H8. Now I have drawn a table where I have written their names, molecular formulas, structural formulas, and displayed formula. Now this displayed formula is sometimes written as full structural formula. As you can see, ethene, molecular formula C2H4, structure formula, I've shown the double bond, and displayed formula, all the bonds are displayed. Propene, again, you can see in the same way, and the double bond you can draw on either side of the propene, that is, I have drawn the double bond on the right side, it can be on the left side, it makes no difference. Now butene. Now here we have 4 carbons, so we have a choice that a double bond can be between center 2 carbon atoms, that is between 2 and 3, and a double bond can be between 1 and 2. Now naming of butene. It depends upon the position of double bond. In A, double bond is between carbon 2 and 3, so we name it as 2-butene or but2ene. Now these hyphens or the dashes drawn are very important. Then in B, double bond is between carbon 1 and 2, so we name it as 1-butene or but1ene. So we should know that the number given must be the least. We are going to choose the lesser number of ethene. So it should be easy for you people because we have been studying covalent bonds and we have been studying dot and cross structures. So the only thing which I am going to mention over here is, you can see that between 2 carbon atoms I have 4 electrons or 2 pairs. So one single bond has 2 electrons. So 2 bonds, that is the double bond, will have 2 pairs in them or 2 electrons in each bond. Now we will study alkenes are unsaturated hydrocarbons. As you have seen that there is a double bond between 2 carbon atoms, noticeably these carbon atoms are bonded to three other atoms, one of which is carbon itself and two others. So the carbon atom has the capacity to be bonded to one more atom if double bond is broken. Remember, unsaturated solutions, which have the capacity of dissolving more solute in them. Due to this property, it undergoes addition reactions. Now these reactions we will study when we are going to study chemical properties ahead. Now we come to isomerism in alkenes. First two members does not show isomerism. Third member, that is butene, can show two different structures, thus showing isomerism. Now as you know, which I have told you before, that isomerism is the property of the compounds having the same molecular formula but showing the different structures. So when we have two carbons or when we have three carbons, there is no choice for arranging them in any different way. But when we have four carbon, we can arrange them in different ways. First, it can be in a straight chain, and secondly, it can show a branched chain where I have picked up one methyl group and I have placed it under number 2 carbon. So this becomes methyl propene. The branched one is methyl and the longer chain has a double bond, 3 carbon atoms, so it is a propene. And as we have discussed earlier, that is butene, as it is a straight chain and can be packed compactly, so it has high melting point and boiling point as compared to the branched one. Now there is a question. Give the molecular formula of propene. Well, you have to go to the general formula. Cn, propene means, prop means 3. So C3H2 multiplied by 3, it comes out to be C3H6. Draw the full structure formula of propene. Now I have drawn the structure formula of the propene showing all the bonds. It is also known as displayed formula. Then dot and cross diagrams to show the bonding in propene molecule. Now over here again, just to mention, where there is a double bond between 2 carbon atoms, there are 4 crosses which shows 4 electrons or 2 pairs showing double bonds. Then question number 2, I have drawn 3 structure formulas P, Q and R. So state one similarity between P, Q and R molecular formula. Well, they are all hydrocarbons. Homologous series of P, Q and R. P is alkane, Q and R are alkenes. And state one similarity between bonding of Q and R. As you can see easily, there are double bonds in Q and in R. Thank you. Now we come to properties of alkenes. First of all, physical properties. Now as you know that physical properties are related to their melting points and boiling points. So as their molecular masses increase or molecular size increase, their melting points and boiling point also increase and their state changes from gases to liquids and then viscous liquids. Or now we come to the chemical properties. Alkenes are reactive hydrocarbons as they have a double bond. They are unsaturated and have a capacity to add one or more atom by breaking the double bond. First property is combustion. As you know, as I have discussed earlier, combustion is burning of a hydrocarbon in the presence of excess oxygen to form carbon dioxide and water in the form of vapors because combustion reactions are exothermic reactions, they produce heat. So I have given the general equation: alkene plus oxygen forms carbon dioxide plus water vapor. Then ethene plus oxygen forms carbon dioxide, water vapors. Now the equation where I have written C2H4 gaseous form, oxygen forms carbon dioxide and water. Now the coefficients, that is 3 oxygens, 2 carbon dioxide and 2 moles of water, are actually to balance the number of atoms on the left and the right side of the equations. C3H6 oxygen forms carbon dioxide and water. Now as you can see that I have written 9/2 on the left side of the oxygen. If you see the atoms of oxygen on the right side, in carbon dioxide we have 6 and in water we have 3. Altogether they make 9. So in order to keep C3H6 1 mole, I write 9/2 with oxygen. Or there is another way. Multiply the whole equation by 2 to get a whole number for balancing oxygen. So I have written the equation again, putting it in brackets. I have multiplied it by 2. So when I multiply it by 2, on the right side you can see, in order to explain, when I multiply 9/2 by 2, it comes out to be 9. So our equation becomes 2 moles of propene react with 9 moles of oxygen, forming 6 moles of carbon dioxide and 6 moles of water. Alkenes have a relatively higher percentage of carbon as compared to alkanes, so they burn with a sootier flame. Sootier flame is actually the unburnt carbon particles. Now the second reaction is addition reactions. These reactions are specific for unsaturated hydrocarbons and hold importance, quite a lot of importance in your examination point of view. The carbon-carbon double bond in alkenes are reactive, so will undergo addition reactions. Simply another element, atom or a group of atoms can be added and a single product is formed. Double bond breaks and a single bond is formed, so unsaturated hydrocarbon changes to saturated organic compound. Now I have mentioned ethene as A and B, which is to be added. A single compound C is formed. Addition reaction of alkenes. Now we can add hydrogen, which is called hydrogenation. Product is alkane. If we add bromine, process is known as bromination and product form is bromoalkanes. If we add steam, process is known as hydration. The product is alcohol. Then alkene molecules, they can be added up to each other. The process is called polymerization and the product formed is polymer. Now we are going to study all these reactions one by one. Now when I am going to teach you these reactions, there are certain conditions for specific conditions for these reactions. You must remember these conditions. Now first of all, addition of hydrogen, which is called hydrogenation. Temperature required is 200 degrees centigrade. Catalyst, nickel. Now the reactions. Alkene plus hydrogen. Now on the arrow I have written 200 degrees centigrade and nickel. It forms alkane. If it is ethene, it will form ethane. Now I have written its molecular formula, hydrogen, and it forms ethane. And their state symbol is they are all in the form of gases. So now another example where I have written the structural formula displayed formula, and I have written hydrogen with red marker to make sure that you understand that these two hydrogen atoms are attached to the carbon atoms where there is a double bond. Double bond is changed to a single bond. So it has changed to ethane. Then I have drawn propene. Again, the hydrogen is with red marker. Conditions are the same. 200 degrees centigrade temperature, catalyst nickel, and you can see the hydrogen atoms are attached to those carbon atoms where there was a double bond. Now here you have to remember one thing, that is there should be 4 covalent bonds around carbon. It should not be like that you are going to, in order to fulfill the molecular formula, you count the hydrogens that they are in the correct number, but if you see the structure, we see this is a common mistake which students make, that is around one carbon there are 5 covalent bonds and in another carbon there are 3. So you must check the structure before handing up your paper. Now second one, butene. Again there are 2 butenes as we have discussed earlier, a double bond between carbon 1 and 2. So it forms butane, and a double bond between carbon 2 and 3. Now the hydrogens are going to be attached to the places where there are double bonds. Make sure to write down the hydrogens at the proper place. Note the position of the double bond and added hydrogen. Now, what is the use of these reactions? So, hydrogenation has a very important use in the manufacture of margarine. Vegetable oil is hydrogenated to produce margarine. Third reaction is addition of bromine, which is called bromination. Now, as you know, bromine is reddish brown color. If alkene is added to a solution of reddish brown bromine, it decolorizes immediately to form a colorless solution. This reaction is used to test unsaturation or to differentiate between saturated and unsaturated hydrocarbons. Ethene plus bromine forms 1,2-dibromoethane. I have written the equations. Now if you can see the second one, where I have drawn Br molecules with red marker, and I have shown the positions carbon 1 and 2, and there is a single bond, 2 bromine atoms are attached. So we have to identify the position of the bromine atom. Therefore we write 1 with a comma 2 and then dibromoethane. So these are the specific ways to write down the formulas. Now I have drawn these test tubes on the right on this page, where there is first experiment where in one test tube we have oil and in another test tube we have aqueous bromine. Oil is unsaturated hydrocarbon. So when we pour this oil into aqueous bromine and we shake them, and we'll see a colorless solution formed, which means that double bond has been broken and bromine is added into it. Now another one, gaseous alkane. Alkene, if it is passed in aqueous bromine, it again changes to a colorless solution, which is the test for actually unsaturation. Test to distinguish between saturation and unsaturation. Now we come to the third reaction, addition of steam. It is also called hydration. Now here the temperature is 300 degrees centigrade, pressure 60 atmosphere, and catalyst H3PO4, which is known as phosphoric 5 acid. Must remember these conditions. Alkene reacts with steam to produce alcohols. Ethene plus steam. I have written the conditions on the arrow. It forms ethanol. OL is the name for hydroxyl groups. We have discussed them earlier in my previous lecture where I have been naming these compounds. C2H4 water added to it forms ethanol. Now the displayed formula where all the bonds are shown, I have written water with red marker, and you can see in one carbon atom hydrogen is attached and on the other carbon atom hydroxyl group is attached. Same reactions I have done with propene, and then with it forms propanol. Then with butene it forms butanol, and again butene has two different places of double bonds. The above one shows that there is a double bond between carbon 2 and 3, so it will form butane 2-ol, that is the hydroxyl group is attached to carbon 2, and then in the second one it will form butane 1-ol, that is hydroxyl group can be attached to carbon 1, and there is an option it can be attached to carbon 2, so it can form butane 2-ol also. Remember, OH is a functional group, so it should be given the least number. Now the another properties of polymerization that I am going to discuss in my coming lecture. I hope you have understood all these reactions, so please comment, like and subscribe my channel.